You'd think crashing into the sun would be the easiest thing in the solar system. It's massive, it's bright, and it's pulling everything toward it with unimaginable gravity. So why do scientists say it's actually harder to crash into the sun than to leave the solar system entirely? Well, get ready, because this is one of those space facts that completely flips your intuition upside down. Let's start right here on Earth. As we orbit the sun, we're not standing still for a single moment. Our planet is racing around the sun at an incredible 30 kilometers per second. That's over 100,000 kilometers per hour. So, when a rocket launches from Earth, it's automatically carrying all that sideways speed, 30 kilometers per second of orbital motion around the sun. And that's the real reason hitting the sun isn't easy. It's not about falling toward it. It's about slowing down enough to fall in. Imagine you're sitting in a car speeding around a circular racetrack. The sun is at the center. If you suddenly turn off the engine, do you spiral into the middle of the track? No, you just keep moving in a circle. That's exactly what the Earth and every planet is doing. We're falling toward the sun all the time, but our sideways velocity, that huge speed, keeps us in orbit. To actually crash into the sun, we'd have to cancel that sideways motion completely. And that means slowing down by 30 kilometers per second, something no current rocket can do directly. To put that in perspective, escaping the entire solar system, going faster than the sun's gravity can pull you back, takes only about 12 kilometers per second of extra speed beyond Earth's orbit. But falling into the sun? That requires removing 30 kilometers per second. In physics terms, it's 2.5 times more energy to slow down and hit the sun than to speed up and escape the solar system forever. In spaceflight, energy isn't just about direction. It's about how much velocity you have relative to what's around you. And in this case, we already have way too much. But wait, you might say, doesn't the sun's gravity pull everything inward? It does, but gravity doesn't slow your sideways motion. It only bends your path. Think about throwing a ball sideways. Gravity pulls it down, but it still keeps moving forward, making a curved path that's an orbit. If you could throw it faster, it would circle the Earth. If you could throw it slower, it would fall down. Same with planets. Unless you somehow erase that sideways speed, you'll just keep orbiting, missing the sun over and over again. When NASA wanted to send the Parker Solar Probe closer to the sun than any spacecraft before, they faced exactly this problem. Even the most powerful rocket couldn't cancel that enormous 30 kilometers per second of sideways motion. So engineers came up with a brilliant workaround: gravity assists. Instead of flying straight toward the sun, Parker first headed toward Venus. Each time it swung past, Venus's gravity tugged on the spacecraft, stealing a little of its orbital speed. It did this not once, but 7 times, gradually slowing down relative to the sun. After each flyby, Parker's orbit shrank closer and closer until it began skimming through the sun's outer atmosphere, the corona, traveling at nearly 700,000 kilometers per hour, the fastest human-made object ever. Without those Venus flybys, the mission would have been physically impossible. That's how hard it is to fall toward the sun. Now, let's flip the situation. When spacecraft like Voyager 1 and 2 were launched, they didn't need to slow down. They just needed to speed up a little. By flying past Jupiter and Saturn, they used gravity to slingshot themselves faster and faster. Voyager 1 gained so much speed that in 2012, it officially left the solar system, and it's still moving outward today, carrying a golden record for any alien that might find it. So yes, leaving the sun behind forever required less effort than falling directly into it. Think of it this way. You're swinging a stone tied to a string around your head. To fling it away, you just let go, it flies off easily. But to make it hit you in the face, you'd have to somehow stop it mid-swing, take away all its sideways speed. That's exactly what it's like trying to fall into the sun. In orbital mechanics, speed is your shield. As long as you're moving sideways fast enough, gravity can't pull you straight in. So the next time you see the sun shining in the sky, remember, it's not just distance that keeps us safe, it's motion. The same speed that carries us through the cosmos also protects us from plunging into our star. In the end, the sun may be only 150 million kilometers away, but in terms of physics, it's one of the hardest destinations in the entire solar system. Subscribe to Scientific Valley for more interesting videos related to space.